let's go through two more examples of simulations. I think these can be kind of tricky because the way you assign values can be different depending on each scenario. So number 3, every Monday a local radio station gives coupons away to 50 people who correctly answer a question about a news fact from the previous day's newspaper. The coupons given away are numbered from 1 to 50, with the first person receiving coupon 1, the second person receiving coupon 2, and so on until all 50 coupons are given away. On the following Saturday, the radio station randomly draws numbers from 1 to 50 and awards cash prizes to the holders of the coupons with these numbers. Numbers continue to be drawn without replacement until the total amount awarded first equals or exceeds $300. If selected, coupons 1 through 5 each have a cash value of $200. Coupons 6 through 20 each have a cash value of $100. And coupons 21 through 50 have a cash value of $50. So a lot going on here. Basically what's happening is they're giving away 50 coupons. Each coupon is then placed into a hat. They'll randomly select coupons until they get to 300. We don't want to give away less than $300. They want to equal, or it's okay if we exceed 300. Each of the coupons kind of has a different value. 1 through 5 is 200, and so on. So in part A, we want to explain how you would conduct a simulation to estimate the number of prize winners each week. Now, what's kind of tricky about this one is they're already giving us numbers. They're already kind of talking about digits. I know that they're giving away 50 coupons. So I'm going to do things a little bit different this time. When I go to assign my digits, I'm going to do just kind of some side work up top here. I'm going to have 1 through 50 be my coupons, since those coupons are already labeled 1 through 50. All of the other digits, so 51 on to 99, I'm going to just ignore these values. I think it's going to be easier to think about 1 as coupon 1, 50 as coupon 50. I'm just going to ignore all of these other ones. I'm also ignoring the very first digit here is 00, so I need to make sure that I'm ignoring that one as well. So first thing I need to do is explain what's going on. So I'm going to say let, and the first kind of category was 1 through 5. So I'm going to set let 01 through 05. I do need these to be 2 digits, that's why I'm putting a 0 in front. Represent winning, and they're going to win $200. Okay, coupon 6 through 20, so 06 through 20 represents winning $100. And my last value here, 21 through 50 represents winning $50. Now we said we are going to skip or ignore some digits. We want to make sure we include that in our writing. So I'm going to say I will ignore 00, and I was ignoring everything past 50, so 51 through 99. Okay, next up we'll talk about what we'll do to show that somebody won $200 versus somebody won $100. Now in the last couple notes we used symbols, like we put a circle or we underlined it, something like that. It's okay if you don't want to do that, to just say you will label each winner, which I think in this case might be a little bit nicer than just circling, because I'm talking about money prizes. So I'm going to say I'll go through the random numbers and write down the cash prize. So I'm not going to use symbols this time. Instead, if I get a number that's like 07, I'm just going to write down $100 next to it. Okay, we're not going to keep doing this over and over again. We want to talk about when we will stop. It says in our problem that we will go until the total amount awarded equals or exceeds 300. So I'm going to say I'll stop once I reach at least $300. Now there's one other thing here that we haven't quite talked about, and it has to do with this replacement. It is possible that as I'm going through, I'm going to get 01 and then 01 again. Is it possible that that person that has coupon 1 can win twice? Well, they're saying that this is without replacement. They're not putting that number back in. So person 1 cannot win twice. So what happens if I get a 1 2 times? Well, I'm going to ignore that. So I'm going to add on here that I'm ignoring, or I will ignore any repeat numbers. Can't have somebody win in the same prize twice. Okay, now part B says perform your simulation 3 times, that is, run 3 trials of your simulation. They want us to start at the leftmost digit in the first row of the table and move across. So I'm going to start here for trial 1, and I'm going to move across. Says make your procedure clear so that someone can follow what you did. You must do this by marking directly on or above the table. Report the number of winners in each of your 3 trials. Alright, so here we go. We're looking for double-digit numbers. So the first one I see is 72. That is a digit I'm ignoring, so I'm just going to cross that off. 74 is next. Too big. 91. Nope. 33. 33 is my first winner. 33 would be a $50 winner. Or 50 bucks. 47 is another $50 winner. 65 is too big. 03, this is a big winner. 03 wins 200 bucks. Okay, I'm going to stop there because that totals $300, and that's when I was told to stop. And looking at my trial, it looks like I had 3 winners here. Alright, trial 2, I'll start in the next row. First digit is 81, too big. 63, nope. 83, nope. 65, no. 66, no. 42, this is a winner. 42 is $50. 70, no. 93, no. 37 is definitely a winner. 37 is another $50. So we're at $100 now. 17 is a winner. And this one wins $100. So we're at 200 now. 59 is a no. 94 is a no. 31, combining them, that's a yes. 31 gives me 50 bucks. So I'm only at 250, so I gotta keep going here. 20 is next. And 20 was the last one that could win $100. So I'm definitely at my 300, or past my 300. This time I had 1, 2, 3, 4, 5 winners. Okay, trial 3. 38 is 50. 44, I believe, is 50 again. Yep. 94 is a no. 64, no. 38, 50 bucks. 91, no. 57, no. 90, no. 19 gives me 100. So I'm at 100, 250. And then 07 gives me another 100. I'm now at my 300, so 1, 2, 3, 4, 5 winners again. In this case, they don't ask you to write what we expect to happen. Part B just said to perform this simulation. We did that. Make sure you don't skip over this part where you're reporting the number of winners in each of your trials. That's what we have here off to the side. So we are done. This problem did come from an old AP exam. This is typically what you can expect to see. Sometimes they might add a part C on here where they ask you what do you expect to happen, in which case that's when you'll say, based on the simulation, I expect there to be maximum 5 winners, something along those lines. Let's go ahead and take a look at the example on page 8. Hey, this example says Mrs. Soto is purchasing donuts from a local bakery that sells boxes containing 6 random donuts. So 6 donuts in a box. She has determined that each box will contain 0, 1, or 2 jelly-filled donuts, which is absolutely disgusting. I hate jelly-filled donuts. Based on experience, Mrs. Soto estimates that there will be no jelly-filled donuts in 50% of the boxes, 1 jelly-filled donut in 30% of the boxes, and 2 jelly-filled donuts in 20%. We want to conduct a simulation to estimate how many boxes of donuts Mrs. Soto will have to purchase in order to have 24 donuts. So 24 means I'm looking for 24 donuts that are not filled with jelly. I don't want the jelly. No jelly happening here. Now, I like to start with single digits. It looks like all of my percents here end in 0, so I should be able to use single digits. Alright, 50% of the boxes, so from 0 to 4 is what I'll say, those have no jelly-filled donuts. Now, at first glance, they're telling me no, so what I would think to do is put 0 here. But really, I want to focus on the donuts that are not filled with jelly. So if none of them are filled with jelly, and each box has 6, this means I'm going to get 6 good donuts. Alright, there's a 1 jelly-filled donut in 30% of the boxes. So from 5 to 7, those 3, there's a 1 nasty jelly-filled donut. Out of 6 means I'm going to only get 5 good ones. And 20%, so I'm going to use 8 and 9 here. Those have 2 nasty jelly-filled donuts. Out of 6 means I'm only going to get 4 good ones. When you're assigning those numbers, make sure you're thinking about what you are looking for. In this case, we are looking for not jelly donuts. So I would use 6, 5, and 4 rather than 0, 1, and 2. So I'm going to describe these real quick in my sentence. Let 0 through 4 represent boxes with 6 good donuts. And just say not filled with jelly. 5 through 7 represent boxes with 5 good donuts. And 8 through 9 represent boxes with 4 good. Okay, again, since we're just looking at numbers, I am not going to use a symbol. I'm just going to write down how many good donuts there are. So I'll go through the random numbers and write the number of good donuts. I am going to be counting how many boxes. So I'll count how many boxes, or I'll count the number of boxes, I guess may sound better. So I'll count the number of boxes needed in order to have 24 good donuts. Alright, we can go ahead and start running our simulation here. Part B says we want to show 2 trials, so I'm going to start trial 1 here. So first digit I see is a 6. 6 means there were 5 good donuts. 7 is 5 good again, so I'm at 10. I'm looking for 24. 6 is 5, so that's 15. 4 is 6. So I'm at 21. I'm very close to my 24. 2 gives me 6 good, so I can stop. This gives me at least 24 good donuts. In total, then, I looked at 1, 2, 3, 4, 5 boxes of donuts. Alright, I'm going to look at trial 2 next. I only need to show 2 trials. So 3, using my numbers above, 3 means there's 6 good. 4 is 6 good, so I am at 12 so far, halfway there. 0 is 6 good, so that's 18. 4 is 6 good, which gives me my 24. So I only need 4 boxes this time. Okay, part C says, how many boxes on average will Mrs. Soto have to purchase in order to have 2 dozen donuts that are not filled with jelly? So on average means I want to find the average based on my trial. So the total number of boxes was 9, that's just 5 plus 4, divided by the number of trials. So 9 divided by 2 should give me 4.5. So I'll say based on my simulation, Mrs. Soto will have to buy an average of 4.5 boxes in order to get 24 good donuts. Hopefully after seeing these 2 examples, you are feeling a little bit more confident with these simulations. They are kind of tricky. There's a lot of writing and a lot of work, but generally they do follow the same process over and over again. So doing more and more examples can help you just kind of seal the deal and get comfortable with this process.